Yeah, my talk was entitled, I think, From Coder to Developer, which is also the name of a book. And the author escapes me, but you can Google that and find it out. And if you're an APL, a young APL programmer starting out, or like me, an old APL programmer who didn't know anything, who spent 20 years doing everything the wrong way, you should check it out too. And that's one good book, and there's another one, I just wanted to mention it because I'll forget by the end, Clean Code, check out that one. And Code Complete, I think that's by McDonald. And these are not APL books at all, but like many of you here, I started out coding in a workspace, just me, and for close to 15 years, maybe 20 years, I worked in the workspace, write, parent, save, and didn't know what a test was, didn't know what a source code management system was. I didn't know anything, and it's a miracle you get as far as you do, and it's really, it's malpractice, but you know, there's a lot. I'm going to talk a lot about, well, maybe a little bit about that today, so at least the title of my presentation will be somewhat legitimate. But the inspiration for that was when I started essentially a rewrite of our main product, which is the one that was workspace bound, and that had no unit tests and it had no source code management. And I started a new project and was aware that these things were good practices, and I knew that we needed them. And so I incorporated them and with this project. And this project called FlipDB it's a relational database management system with a rich front end. So it's sort of like Microsoft Access, but sort of not, if you know what I mean. It's like if KDB were sort of like Oracle, then this would sort of be like Microsoft Access. But KDB is not like Oracle, so this is not quite like Access. So anyway, I'm going to show this, and I'm going to move fairly quickly, and then get into source code management and just some, you know, how I do testing, and particularly a couple little tricks with testing GUI. Because when I started doing this, I started on this database engine, and it was just an object model, and it was fairly easy to write tests. There was no GUI, and you could just, you know, write a little test that returns a 0 or 1, exercises some code, and you're good to go. But I hadn't revisited GUI in a number of years, and a lot of my GUI techniques were untestable, not through my own fault. And if you don't code to your tests, or you don't think about testing as you're coding, or write your tests first, even better, you'll end up with untestable GUI code, and that's not good because GUI ends up being 90% of your application anyway. So okay, without more about that, let's get right into it. So this is the session of FlipDB, which is just like the dialog session, really. It's a session for you to enter FlipDB expressions. And FlipDB also has, just like dialog, an Explorer, but the Explorer is probably the first screen that a user would see. Most users, you know, would not come into this session. But for those of you who are into languages and sessions, as we all are, this will be more fun for starters. So let's see here. Is this working? Okay, so FlipDB has data types, and there's a complete language called FlipDB, of course, and there's booleans, integers, and characters, and wide characters because we're in Unicode, so we can do those. And there's extra wide, but I didn't put them on there. Most of those are, as you can imagine, pretty thin covers for your favorite dialog data types. We have assignment, but we use the equal sign for assignment. And I'm just going to assign a couple of variables here. And I'll come back to that a little enclosed thing. That's a function, as you can probably imagine, but we're still talking about variables. And variables have structure, and there's only 4 structures, so we limit what you can do. It's not completely generalized arrays like dialog or APL. So you can have scalars. Starting from the left, you can have a scalar. You can have a vector, or what we call a simple column. Because FlipDB is a relational database that is designed to work as you can imagine, with columns of data. These are actually called data columns. And so I have a scalar data column, a simple data column, an enclosed data column, and a partitioned data column. And you can guess that it's a little, basically a little nested array, an enclosed vector, simple vector, but we show it vertically, so it looks like a column. And a little arrow indicates, of course, that it's got some dimension to it as opposed to the enclosed or the scalar item, which don't. And this, I'm not sure you know how to use that thing. Okay. We have functions. All right. So there's scalar functions, symbolic ones, plus, minus, times, divide. There's some keywords for all the rest of the things that you know and love in APL. Functions, we all know what they do. They're good. Functions come in what am I going to talk about here? Functions can be one of 4 different types. There are scalar functions, and these are scalar functions. And they're rigorously defined. These are summary functions, and sum is a summary function. And this shows how the summary functions work on different data structures. So you can see that if you if you sum a simple column, you get a scalar. You sum a nested, you sum an enclosed column, you get a scalar. If you sum a partition column, you get a simple column, right? And there are hybrid functions. And is this a hybrid function? Yeah. These functions are kind of a combination between a scalar function and a scalar function and a summary function. If you think about a column in a database, or a vector that you rotated around, and you think about the rows in there, scalar functions, of course, are row independent. Whatever you do to this row, if you add two items in a row, the other rows don't matter. You can add more rows or what have you. Summary functions are, of course, row dependent. If you add another row, you're going to get a different answer when you sum it up. The prototypical or the quintessential one of a hybrid function is plus scan, which not only does the result have the same shape as your starting column, so it's not a summary function, but it's row dependent. So it kind of combines, scalar functions and summary functions. So we have those types of functions. And just to repeat our little bit of data there so we can see that. And then we have anything that doesn't fall rigorously into those 2 categories is a structural function, which does all the usual things that you do, reshaping, taking, dropping, and things that come out with different shapes. Okay? Okay, so there's another little, just repeating that little partition column there. That must mean something. We have operators, just like we have in APL. So you can have, there I'm using 2 different operators. I'm doing for take each of D, which is going to pad those out. And then there's a cross operator, which applies the scalar function plus across these items that are now the same shape, and so it'll work. So there's operators and functions that are just like APL. So we have functions, operators, and data columns. And we can also, because we're a database, we have to deal with tables. And tables are first-class things. And you can construct it. This is constructing a table by using 3 columns and then naming them. So T is a table object. Now, those data columns are like APL arrays. They don't have properties or methods. They're not really objects. They're just data. But, whoop. I don't like that thing. These tables have properties and methods. So this combines data or arrays with objects, just the way you do when you're in your dialogue session and you use some .NET thing or you use some class that somebody uses. And I think it's one of the genius things about dialogue is the way we use objects and arrays all mixed in, and we have arrays of objects and objects of arrays, and it all just works really nicely. And this does the same thing because, of course, we're just a very thin layer on top of the dialogue interpreter. So we have methods here: row count, column names, get a column, so we can extract a column from the table. Anything you might want to do to data table. This is actually officially a data table object as opposed to a table object. A data table is just a collection of named data columns, whereas a table, which we'll see next, has a life on disk. It's tied to some persisted thing on disk. So I can access a server here. I have a server object S. And there's only one server object in the session, and that tracks all my databases and all my tables. And I'm going to delete a database if it exists, called S&P. And I'm going to, I'm going to build it new using a built-in method called the build suppliers and parts method. If anybody's ever done any database work and you read the famous book by C.J. Date, he uses this little database in all of his examples. So we just build it right in here. I can extract a table using the getTable method of the database object. So D is a database object, and ST, should I make that bigger? Can you guys see that in the back? Have I heard that? All right. So ST is a table object, and I'm going to get another one. PT will also be a table object. So that's getting the suppliers table and the parts table, and we'll take a look at these things. So there's the suppliers table. Shows some supplier numbers, some supplier names, a status, and a city. Notice that this display actually shows the name. So we know that this is a table, not a data table. The data table has no name associated with it. And let's show this little parts table here. So we have a parts table. And we could do some things with these tables. And we support all the usual things that you do with tables. You can do inserts, updates, deletes, and all those sort of things to the rows. But I'm going to show something a little more interesting because everybody knows what those things are. They're not that interesting. One of FlipDB supports what's known as multiple assignment. And multiple assignment is a fancy word for, well, I guess multiple assignment. You can take for transactions, essentially. If you want to add some rows to a table and you want to simultaneously add some other rows to another table, or perhaps delete some rows from a third table, you want to do a bunch of little things, and you want that to be an atomic unit, atomic transaction, so that if it either all works or nothing works, there's two ways you can do that. One is the concept of a transaction. You begin a transaction, you do some stuff, and there's rollbacks and complicated stuff like that. The other way is to use something called multiple assignment. And you basically gather up a few of these things, and you do them all in one shot. And FlipDB does that. And you're guaranteed that either all of them are going to go or none of them are going to go if you pull the plug or what have you. So in order to do that, we, for the insert, update, and delete methods that you would normally expect, we have corresponding ones as well, called deferred insert, deferred delete, and deferred update. So here I'm creating a deferred update. And I'm going to update supplier number S4, and I'm going to change the status to 50. It's probably 20 or 30. And nothing has happened there. I just created this thing called an assignment, right? And if we look at it, it's just a little bit of data, and it knows that it's going to be assigned to a table at some point, and it knows what kind of type it is, and it knows the values. But nothing has happened, nothing has changed. All right, so let's do, okay, so now I'm going to do a deferred insert as well. So I'm going to add a new part number, P7, and I'm going to, it's be called a nail, right? So then I can use the database assign method to take these two assignments, and I could take more. I could take a dozen of them, and they are going to simultaneously change the database in one shot. These are actually both going to the same table, aren't they? No, they're going to two different tables. Okay. They could go to the same table. So I just did that assignment, I think. Let's see what's next here. So we can look at the parts table, and I have a nail there at the bottom, because that's new. And I'm looking at the supplier table, and I've changed the status of supplier S4 down to bottom to 50. That's all good. I guess you'll have to take my word for it that it really did what I said it did, because you really wouldn't know that. Now, the other neat thing about FlipDB is that it is what is it? It supports something I call XMVCC for Extreme Multivalued Concurrency Control, okay? I just made that up, it sounds cool, it's a new acronym. But MVCC, Multivalued Concurrency Control, is one technique for databases, relational database management, to deal with multiple users getting a consistent look at the database. So if you have multiple users doing reads on a database and someone's doing updating, if these things take a long time and there's some interaction going on, you can get an inconsistent view of the database because someone has updated this table while you're halfway through looking at it or what have you. One way to get around that is by something called multi-value concurrency control, which means they don't overwrite values immediately. They keep them lying around for a period of time so that if you're looking at the database and someone's changing something, you're not going to see those changes until your transaction is done. With FlipDB, there is no destructive update at all, period, ever. So you can have one person writing to the database and someone else reading from the database, and the person reading will always get a perfectly consistent view because nothing is ever destroyed. So when they come into when a user comes in for a report or something, a query, and the database is effectively stamped for them, and they say, okay, the database is as of this transaction number or this certain time whenever you come in there, and any activity that goes on changing anything happens literally below that, happens after that. And when I say after or below, that's really the same concept. Because nothing is ever overwritten, and we'll see this, you'll notice here that when I changed this guy here, I changed his status to 50, my supplier number order changed. And now in traditional relational database theory, a table has no ordering. But FlipDB is not exactly 100% traditional. There is an ordering, and the ordering is of the data in the database is by time, by update time. So we didn't really overwrite that. There's another hidden row in there somewhere, and we turned a row off and we added a new row on. So time is length, and you can go back in time by merely truncating. Okay, so one thing we can do is we can ask the query object. We can do a query on the supplier table as of one transaction ago by using a little -1 there, and I can see the data as it used to be. So there I do the supplier number S4 is still 20. His status is 20, not 50. So I just went back in time there, which is handy. And okay, so that's I think all I wanted to show there. Now we're going to move on. I'm going to delete that database because I want to create it fresh again. I'll build it up here. The ability to do reports as of any point in time is great. You know, if you have an end of month report, you don't have to save it. You just say, show me the report end of month. So every query has an as of property, basically. That can be a timestamp or a transaction ID or something like that. Okay. I think we'll have time for questions. If you really want to jump in, you can. I think we're moving right along, so there'll be plenty of time for lots of questions if you have any. I want to show a little more in detail about how queries get done. And this is the third table in this little example, which shows suppliers and parts cross-reference table. So it shows supplier number, and it shows that supplier S1 supplies all these parts in these quantities on these dates, and you can see that supplier S4 supplies these ones, supplier S2 and 3, each supply a couple of different parts, and supplier S5 I think supplies no parts, or S6. S5, there's only 5 suppliers. So this is a little cross-reference table that goes with those two suppliers and parts tables. Queries are done in FlipDB by getting a query object, which has properties that you set, rather than writing a big SQL thing. So Q is a query object, And I get it by using the query method of the table that I want to start my query on. Of course, we can reference other tables in the query. So I can set some properties of this queue thing. So I can set the select property in a very simple way, just grab a couple of columns there, and I can execute it. And that just grabbed a couple of columns out of that table. That returns a data table. A query returns a data table from a table. It can also operate on a data table and return a data table. Notice there's no name up there. That's an unnamed thing. Now, because we have some methods here, because it's an object, we can use some of the other methods to incrementally tweak this query and run it again instead of starting it from scratch. So I can add a column, which is a handy way to basically add a new item to your select property. And the result of this is actually what the select property now looks like. I initially assigned the select property to be 3 columns. But that is shorthand for what it truly is, which is a mini data table of name and expression, and maybe some other things as well. So I have 3 things that I had before, and then I added a new one, which is going to link, actually, to get the weight column from the parts table. And to do that, I do what is known as foreign key hopping. So PNO, part number, is a foreign key in the suppliers and parts cross-reference table. And the foreign key implies the other table, the parts table, where the weight is. So that's a short, basically we have this long table, suppliers and parts cross-reference, and we have that little short table with the parts numbers in it. And we're just going over there, getting the weight, looking it up, looking up the keys and expanding it so it all lines up nicely, right? Dyadic iota does it all, and nothing fancy going on there. We can execute that and get the weight. So we basically did an implicit join. There's no explicit joins in FlipDB. Everything's implicit. We can group, so I can add a grouping to this same query. I just sunk the result in there. Didn't do anything. We can execute that. And now notice here that when we group, 2 interesting things. One is because I'm grouping by a foreign key, it's smart. It knows that. It knows that there's an item that we actually have no data for in this table. So we have an empty row for that. But also notice that we grouped, but we didn't summarize. So it gave me these partition columns as results. So grouping does not imply summarization as it does in many other databases. I'm going to clear out the select property because I want to do some summarization now. And I'm going to add a column. I always, whenever you're doing summarized groupings in SQL, or you get these long expressions and everything, I like to do it line at a time because you're going to have a complicated expression, so you just have a series of names and expressions. So I often do something like this. I'm setting up a select property here, adding a couple of columns with a name and an expression, right? Total account, a weight, and run that again. Actually, I didn't run it. I just showed you it, and that will run it. All right? So we're doing some summarization there. And we can also do, if you think about what a query is just a program. And a program that runs these things, that runs all its properties in a certain order, and when it gets to the select property, it runs through that in order. So it evaluates this, then it evaluates this, and evaluates this. And we can refer to any of these in any subsequent expression. So here, I want to get the average weight, so I can just round the total weight by the shipment count, which are 2 previously defined things. So I can do all that in one shot there. And I think I did it twice or something. Go back up there. Yeah. I think, let's see here, try that. No, I don't want to do that. Let me go back to, oops. I know what I did here. I think I added it twice. Let's go up here. Let's do that again. And let's execute that. Okay. Let's just take a look at this again. Oh, there you go. That's not good. There's junk on the end there. Okay. Oh, now where am I here? Ooh. I'm hosed here. Let's execute that. Q.execute. Okay, so we just computed that column here based on previous values. All right, let me find where I am here. It was going so well, I thought. And now I've hosed myself here. Just bear with me 1 second while I get back to where I want it to be. 7. I think I have to go back. Ah, there we go. Okay. Here I am. Okay. I wanted to get the suppliers table for this next example. Remember the suppliers table shows just the suppliers. There's 6 different suppliers. And we're going to get a query that's going to operate on that. And a little select property. Now here is another technique. There's 2 ways to do, if you think about database tables, you always have 2 tables. You're starting off in a table, there's some data in some other table that you want, and you need to get it in the table that you're in. And that's how I think of joins. And there's really only 2 ways to do it. There may be 3 ways, but you have a short table, or you have a long table over here and a short table over here, and you need to look up some data in the short table, replicate it so everything lines up, and stick it in the long table that you're starting with. That's one kind of join. The other is that you've got a short table, in this case a suppliers table, and you've got a big table that has multiple items in it per row of the short table that you're in. And in order to get that stuff in any meaningful way in your current table, you've got to sort it, partition it, and line it up. And that's what this little line does right here. I want to get a column that tells me what supplied parts, what parts are supplied by each supplier. And this says, okay, go to the suppliers table. Now I'm starting in this little short table. Go to this table, which is bigger, longer, and look at the foreign key supplier number, which points back to the table that I'm in, and get me the part number. It may sound complicated, hopefully it doesn't, but it's really very simple, right? It just says, I mean, you know what's going on there. You're all APL programmers. It's really simple. You're just looking it up, partitioning it, and closing it, and lining it all up to match your table that you're in. So this shows me what parts are supplied by each supplier. S1 and so on. So S5 doesn't supply any, right? So there aren't, rather than having left joins, inner joins, outer joins, you know, theta joins, beta joins, all these different joins they have, natural joins, they're all too complicated for me. I don't like them. This is much simpler. You can basically, it's really iota, right? Dyadic iota. It's all you need. There's one more thing that's useful. And I'm building up a query here that I want to ask the following thing. I want to know, I want a query that tells me which supplier supplies all the parts. So which supplier can I rely on that supplies every part that I need in whatever this silly example is, okay? So you can, by inspection, you know which one it is, right? It's S1. It supplies all the parts that are in the parts table. So this is a little bit, this is getting me where I want to go. This is getting me to, this tells me, you know, what parts they supply, but I need to compare this list to all the parts that happen to be there. So one way to do it is with this other little bit of syntax. Sometimes you want data from another table that relates in no way at all to the table that you're in. It's just data. So you can use this syntax, which basically says, go to the parts table, get the part number, enclose the whole thing as a scalar thing, so it doesn't have to line up or match in any sort of way, because a table can have scalar things in it, and we use the concept of scalar extension, just as analogous to the APL scalar extension. So this is really handy. I have here a table, and I'm ready to really get to work on it. I know my suppliers, I know what parts they all supply, and I have a list of all the parts. So I can start doing some things. I'm going to execute this query and assign it to a result, exactly the same query, R, just so I can do a couple of things with it, because I want to show you the answer without actually doing it in the query. We can extract from that table a variable called the supplied part. So I'm just extracting a column out of there just to play around with it. And I can extract all parts. I just grabbed this column and this column out of that data table, so I can play around with it. And one thing I could do is I could use the in function and say, hey, you know, see if check this column, see if it's in here. And that does something, but I don't think it's quite what I want it to do. I really need the each operator. That gets me a little closer. So I can run that, and we're beginning to see where we're going to find out the answer. All parts in each supplied part. And then I can do, I need to really summarize that. I can use the all function, and that tells me the answer there. So that flags the right results. And I could use that in a having clause. I could apply that after the fact. So queries have other properties like having and quotas and all sorts of things that you might want to do in a query. That's one way to do it. There it is. And finally, I could just do it in one shot there like that. So that's how you would say, give me all of the suppliers, list the suppliers who supply all the parts. Right there. That's your selection statement, and this is using a method which creates and executes a query on the fly without creating a query object with a where clause and a select clause, basically, 2 entries. So that's FlipDB, and that's the session, and that's the database behind it. Of course, this is all useless. This is useless for everybody or anybody that I know, because who needs a database? Really, you need something on top of it to do something with. It's amazing. There's, you know, you get a PC and it's nice, it does a lot of things, but it's useless, right? You got to have Windows on it. You get Windows, and that's good, and that's nice, and it's useless because you don't have Dyalog on there. You get Dyalog, and then you spend a couple of years writing some code, and you think it's all nice and good, and you realize it's useless because you don't have a GUI on top of it, and so on. So we need a GUI on top of this, and that GUI is, part of it is right here, this Explorer. So you can imagine what an Explorer does. It just shows you everything that you have on your server that you happen to be pointed to, and it's a bunch of junk there, really. But there's 2 main nodes on this thing. At the top, there's it's a tree on the left, it's a tree view on the right, just like any little Explorer type application. We can go in and we can do things. We can create databases. We can look at the databases that we have. There's a let's look at that suppliers and parts database, which I think I probably created 1 million times here. Here it is. We can look at the tables. We can go into a table. We can look at the columns in the table. You can do all the things that you might want to do, create new columns. You can set keys, change types, and you can do all sorts of things. And there's a rich GUI on top of this for interactive analysis, data mining, editing data, doing all sorts of things that a power user might want to do to a database or a set of databases. Importing and ETL, extract, translate, and load, a bunch of things. So this gets us to now some of the things that to manage this development process and back to going from a coder to a developer. I think the two biggest things are source code management, which means getting out of the workspace and having a complete history of all the changes to your code, and being able to have multiple users edit the code, change the code, multiple developers do that. And one of the first things that we did, turns out FlipDB, of course, never overwrites data, and it's a database, so it's a really handy thing to do a source code management system in. And one of my colleagues, Phil Last, did exactly that. He wrote the first application with FlipDB as a server, which FlipDB, by the way, is also multi-threaded, multi-user if you start it as a server. Here I'm using it kind of as a standalone user. So we have a server running back in Pennsylvania, and it has an instance of FlipDB on it, and all the code is in there. So FlipDB is stored in FlipDB. And so that allows, obviously, I mean, some of you, I'm sure, use source code management systems. If anybody's programming and doesn't use one, doesn't matter what you use, get it. Go out and make it the first priority that you have if you're not using source code management of one sort or another. There's a couple of really the usual stuff that would apply to any development process in any language, of course, is that you have a history of all your changes. You can go back and see what was changed. You can do builds that, if I want to produce a version as the system was 6 months ago, you can do that. But in APL, with the traditional workspace development, there's a couple of additional benefits, is that the way we have it set up, and I think the way probably you can do it using Dyalog's tools as well, is I haven't saved the workspace now in about 4 years. Every time I change a function, it's immediately handled by the source code system. So if you do have 17,000 Dyalog windows open and you get in 1,700 threads and something happens and you can't write parent save or something like that, you're golden, because everything is saved instantly as you do it. Nothing is ever overwritten, so you don't worry about, oh, I didn't really want to save that, because you can easily go back and get what you did. That right there is worth the price of whatever it was. So source code management, and in fact, let's take a look at what we kind of, just very little bit here. So I'm all in the same session here, so I just, what do I got a couple of things open here. Let me close them and get to my workspace. This is going to degenerate now because this is not a scripted part of the talk. So if I get off track, you just yell at me. Let's see, are we in the session here? Let me close that. Okay, so now I'm just in I think, something's still open here? Kind of asleep, okay. Okay. I'm in a good spot. All right. So at any point in time when I'm coding away, I can do a couple of things. One is I can ask my source code management system, which is called Acre, to report to me what's going on. And it goes off, and it tells me a couple of things. And wow, somebody's been busy here. Somebody else has, that's interesting, remote changes. That's not right. No. No. No, that's really bizarre, isn't it? No, Kai must be using my my ID or something. I don't know what's going on. That's really. I just did this about 2 minutes before the presentation. Also, I wasn't expecting to see that. That's really interesting. Phil, we'll have to have a beer and a chat about that. What this does is it shows me that there's some other changes that I could check out, you know, from this code base. Bizarrely by me, that I think I checked in a while ago. So, it also shows me that Kai has done a little bit of work. And you can see here that he was doing a couple of things. He replaced 4 functions. It also tells me that I have some unsaved changes here as well. Things that I've been working on that are not saved off. And I can save at any time without doing an official check-in, which also writes my changes back temporarily, so that if I lose my laptop, one of the goals, of course, with source code management is that you can lose your laptop at any point in time and not give a hoot, because you just get a new laptop and you get a copy of Dyalog, you hit a button, and it checks out your code base. So as you work, you can, you know, save your changes back off to the server, and that's a good thing, that you never want your laptop to become very valuable. And this will also tell you if you have 2 people change the same thing, and you can go in and mess around and, you know, reconcile those changes if you want. There's not, other than you know, the fact that you can have multiple users doing stuff, there's not much more to be said about source control. I mean, I'm sure you could talk about it for days, and books are written on it, but it's something that you really, really want to have, and have it in a work group, because otherwise you really can't track what you're doing. Okay, test. I think the second biggest thing, it might be the first biggest thing. I think if I had only one thing, I would take testing over source control, if I had to pick between the 2 of them, but you should have both, obviously. And if you've ever written a system and you didn't think about testing, and you think then about testing, you will get sick to your stomach and go throw up. That's how bad it is to think about starting to write tests on an existing system. You will get dizzy and you will get sick, physically sick, because it's a horrifying thing to think about how much testing you need to do. It's so overwhelming that you will probably not do it, which is what I did. I didn't do it. Instead, I said it'd be easier to write a new system and write tests for that, which is what FlipDB is. So I think we have something like 600 tests now, and a test is just a APL function that returns a 1 or a 0 that requires no setup to run. You just hit enter on this. It's a function, right? It's a function. And I want to show a couple of tests. Now, tests that do test things, like if you want to test that 2 plus 2 is 4, it's pretty easy. You just write a little function, you put 2 plus 2 in there, you see if the answer is 4, and you return a 0 if the answer is 4. You return a 1 if it's not, or vice versa. And if the function doesn't run through and crashes, that's another case that you can trap. So you basically have the function runs and gives me the right answer, the function runs and gives me the wrong answer, or the function crashes because I deleted a function and I forgot to, you know, change the name of it or rename something, right? So you basically have 3 conditions there. If you think about testing before you code, or as you're coding, it will change the design of your code. You will not write untestable code. This is why it's so hard to think about testing ex post facto, especially with GUI. But even in other areas, you will write code that, if you're not thinking about it, you will write code that is untestable or very, very hard to test. But if you think about it ahead of time, and even better yet, write your test first, you will write code that is eminently testable because you wrote the test first and you wrote the code after the test, or you wrote them both at the same time. Testing, again, something like 2 plus 2 is not that hard. Testing GUI gets a little harder. And when I talk about testing GUI, graphical user interface, I'm not talking about the color's right, is the pixel right, is the button attached to the bottom right, so when I redrag the form, the thing's, you know, the thing goes in the right position. I'm talking about the functionality of the GUI. If you click on something, if you hit a key, does it all work? Does the autocomplete work? If you click OK on file save, is the file saved? If you open a database, is it open? Those things I thought were hard to test, and they were hard because I wrote my GUI before I started writing tests, so I had to go back and rewrite it all after the fact, and it turns out it's much better. And in fact, many times you have a design issue, and How many of you have written a function that gets a string, a little GUI function, gets a string for maybe saving a file or some little purpose, some utility. Maybe it just gets a string and returns the string, right? And you write the function, you start at the top, and you may pass an old string in a default value. You go through, you build a form. You may have some tools for doing that, but bottom line is you got a little form, quad WC, create a little form, put a button on it, dress it up, maybe pre-populate the values a little bit, and then, okay, I got to wait for the user, so I'm going to do f.wait or quad W, quad DQ on the form. And then after that, user hits OK, so you put a 1 on that to exit the quad DQ. Anybody written a function like that? Anybody? Okay. Anybody think that's a good idea to write a function like that? Turns out it's a really bad, terrible, terrible way. And I've been doing it for 20 years. And it's horrible. It's untestable. And it's untestable because quad DQ is not your friend. And there's many things like this. And there's another thing that's not your friend that you think are your friend for many years, and you realize they're not your friend, and you have to get rid of them. And the quad DQ there is a modal form. If you try and test that, you can go spend hours and hours and hours, and you'll have no way to automatically run that function and have the system click OK for you and have it continue on because of the nature of wait states and all that kind of stuff. And I don't know if that's specifically Dyalog or other languages, but it doesn't really matter. You're going to find something, whatever you write in, that you're going to do it in such a way that makes it untestable or very hard to test. So it turns out the little thing that you need to know there is that you can use the wait, but it has to be the last line of your function. There could be no code after it. And the wait then does not need to be run during the unit test because you can just leave it out, which means that everything has to happen in callbacks. You never want to wait, look at the result of the wait or the quad DQ and use that information. That's not a good way to do things. So let's look at a test here. I've got a whole bunch of tests, and we'll just see how this works. Got 10 minutes here. Change space. Let's make this a little bigger here. So here's a suite of tests. And most of these are all, these are GUI tests. They test that Explorer. They test that if the user right-clicks and puts a pop-up, he can create a new folder, or he can create all these items, and he can delete them, and he can rename them. You can see from the name of the test, right? Then there's a bunch of these little delta functions, which are little utilities to help me test. And no matter how you write, if you use a testing framework, doesn't matter. It's good to test. You can set up your tests any way you want. Doesn't matter. This is not about the framework. It's just about why you should test. Which I probably didn't say. I mean, the reason you want to test, of course, is so when you go make a change, you have confidence that you can click a button and send out a release tomorrow morning and not, again, get sick to your stomach that you didn't do something right. But there's actually other reasons for testing. That's one of the most primary. But so I want to look at this. In order to test, I actually have to have I have to have an instance running of application. Test. In FlipDB, the application object is it's a programmer object that basically is the root thingy that you have to do anything. And it's clearing out and creating some databases and stuff. So I have this thing. And I'm going to look at test rename object. Okay. What was that? Oh, it made some noise. Okay, so let's look at this code here. There's the test function. And this function, actually, all I really cared about, because I didn't have, well, I probably should care about some more things. I just want to get to the bottom. I don't even have any guards for wrong answers. It's just, it'll crash or it'll get there or not. One of the things you want to test for is it's very satisfying when you're starting just to get code coverage. Whether the thing gives you the right answer or not, you don't even care about. Just does it actually execute? So I need to know that I'm in test mode, because one of the key things is when I'm in test mode, I don't want a quad DQ. Why do we do a modal dialog, a modal form at all? You do a modal form because you don't want your user to do something else, right? While he's entering that string. You don't want him to go do all these other things. When you're in test mode, you don't have to worry about that. You don't need the form to actually be modal, because there is no user doing anything else. The computer is doing exactly what you want. So we don't need to have the wait actually run. So let's run this. It'll be a little, let's trace it. So actually, before we do that, let's run it. See what happens. It does some stuff, comes back, it works. Got a 0. Nice. All right. What happens there? Let's see if we can get some of this on the screen. So you end up just developing, whoops, do that. Trace through this little test function here. And just going to get a server object there. So this application object, which is the right argument, is already up and running. This starts up the Server Explorer. So it started that, and there it is over there. Of course, we really don't want to ever DQ this thing, right? Because this would not continue running. And this is a top-level form anyway, so you would not do a wait state on it. There's just a wait state on the whole session. This answer, when you test things, it also answers a lot of questions that you have as a rookie. Like when I start my application, do I DQ the form or the session? You know, who knows these things? You know, you figure them out the hard way. If you test, you find out a lot of things the right way the first time through. So go back to here. So I can now, see if I can, so we can see some of this. Whoops, not that, that. I have a little utility function to select a tree view item, right? So it's selected the thing on the left. And I can effectively do exactly what would happen if the user right-clicked and selected an item off a pop-up menu, but it could be from a main menu. That's what happened there. So we put this up. Notice we have no modality here. I can move both of these right now. And I just generate a little name. Oh, wow. That's going to die faster than it. No wonder the thing was kind of slow. I was falling asleep there. Is this one live over here? Okay. So then I have a little enter string function. If I click on this thing, I'm gonna, you know, it'll actually enter it and hit OK because it's a utility. Let's trace in there. So that's a little utility function. So it puts the string in, and then it clicks the OK button. You'll develop your own. You know, these are, and this has nothing to do with dialogue, really. I'm sure if you do, I want to see the WPF presentation tomorrow. I need to learn a lot about that. I'm sure you're going to find the same things. You need to test ahead of time. It doesn't matter what framework you're using. So now I can select a list view item. I've selected the item I did there. I can rename it. So I'm doing another little thing here. I'm going to rename it to that. Oops, lost the focus there. Okay. And I should expand this test because I should check that that thing now exists. I didn't even bother to do that. And then I can close it. So it just ran through all that code. This gives you a lot of confidence. If you're like me, I always delete a function, get a value error. You know, it's really embarrassing. This helps you avoid doing that. The other really important thing about tests is that you develop a library of these tests. And the tests become essentially more important than the code because the tests are the specification. The test tells anybody looking at it how the thing should work. The test tells you, looking back at your work, what you expected this thing to do. The tests are documentation. And a test being in a function is a useful thing. We have, with the dialogue session, we are blessed. How many people love the session? Type 2 + 2, it gives you 4, right? It's a blessing and it's a curse. It is so seductive. You go into the session and you write a little function, and you try your function, and you see what it does, and you look at it, and you do something, and you play around with the L a little bit more, and you say, oh, it works, that's good. And you have just thrown away 20 minutes of your life or 15 minutes of your life, because while a session is nice, a session is ephemeral. A function is forever. And a function, if you were, instead of typing that into the session, you typed it into a test function and you gave it a good name, you have now something to show for your work. And it is so seductive. You know, I'm sitting there every day because I'm a recovering, what's the word for someone who doesn't write tests, you know? A recovering something. So every day it's a struggle because you want to just write somebody tells you there's a bug. You get a phone call. And what do? Oh, you try it out, right? Or you go, if it's a GUI bug, you go in and you play around with the GUI and you right-click on something and you do what they said. It's a total waste of time. You should write a test, and you write your test, and the test can go in and do that GUI stuff, because when you're done with that, you have something useful. Now, sooner or later, you want to use your GUI because you want to make sure the buttons are in the right spot. But when you're writing it, you play around with it a little bit. But if you write that test, you now have something permanent, something of value that will last years and literally decades if you're working on a project of any significance. Whereas if you type into the session, so I feel like I wasted the first 20 years of my coding life because it scrolled off the screen. And it's embarrassing. Whereas now I have 650 tests, which probably have, I don't know how many lines of code in them, but there are some are 10 lines, some might be 100 lines because I might do a lot of tests in one thing. And it is invaluable. It tells you what the system should do. And I can't stress that enough. So if you're not doing it, and I'm sure some of you are, test and source code management. And I think as an APL, I got 30 seconds here, as an APL community, we don't really stress these things very much as we should. And I think other folks, like the Ruby folks, are a little more into it, testing and things like that. So that's it. Thanks. Thanks. And thank you very much.